Hi, this is Chris, and we are going to take a look at what it looks like when you go to graph a log function. So first things first, and we've shown it in some other videos, so if you haven't practiced converting a log function into its exponent form, then make sure you take a look at that, because that's a skill that will make it a lot easier for us to graph it and for us to wrap our heads conceptually around where the graph of a log form originates. So if we have something like this, y equals log of x. So even though it's not written in, there is a base on that log, and your standard log base is 10. So just like, for example, if we're writing out, let's say, a polynomial, if you write x squared plus 2x minus 3, so the x squared still has a coefficient. It's a coefficient of 1. You just don't have to write it in. Or if you have an exponent on a variable, like if I say 5x, it's really 5x to the first power. We just don't have to write the 1. For logs, you don't have to write that 10. That 10 is assumed whenever you're talking about a log function. So logs are going to be standard base 10. So if we have y equals log x, it's like saying y equals log base 10 of x. And to convert that into exponential form, so we're going to do our cross switch method. And again, if you haven't mastered that, go ahead and take a look at our other videos on logs. But here, this would be 10 to the y equals x in its log form. And we don't have to do a million values here to get the basics of what this log function will look like as a graph. So let's just do a couple values. Let's try when y equals -1, 0, and 1. And so what you're probably used to when you have an xy chart is you're probably used to picking those types of values for x and then solving for the corresponding y. But since your log conversion into its exponent form is going to have an inverse relationship with your y and x, it's actually going to be easier to pick these values for your y and then solve for the corresponding x. So here, when we plug in a -1, 10 to the -1 is the same as saying 1 over 10, or 1/10. 10 to the 0, just like anything to the 0, is 1. And 10 to the first power would be 10. So let's go ahead and see what that would look like on our graph for y equals log of x. So here, we're going to do plenty of space here. We'll do -1, 0, and 1 for y. And for x, we'll do 1 here. And then I'm just going to ballpark it, but that would make 10 roughly about there, let's call it. And so here we can see that when y is -1, we're going to be at 1/10. So that might be maybe something like this. When x is 1, y is 0, that's going to be your x-intercept. And this is a point that I would make sure to understand and memorize for log functions, because that is basically your anchor for graphing any sort of log function. Unless you have a shift or a transformation, which we'll get into, when you're translating a graph left or right, up or down, whatever the case may be, then that'll alter that intercept. But when you're looking at your basic log function, that intercept is really important. And then all the way out here, you might have a value of 1. And the shape of your graph is going to be something like this. You would have an asymptote right there along the y-axis, and then this graph is going to continue in that positive direction towards infinity for x. So this is your general shape of any log graph that you deal with, minus the corresponding translations or transformations that you might make to the graph in more advanced questions. But for right now, that is our basic outline of not just what a log graph looks like, but how we can use an XY chart to come up with appropriate values in order to graph that manually. Whenever we get stuck, we can always rely on the coordinates to tell the story of the shape of the graph. For more, stay tuned, and we'll take a further look at log graphs in our upcoming videos. Thanks for watching.